Hello, welcome everyone, welcome back to my channel. As you know, I have started a series for Further Maths where I'll be discussing all the topics. I'll be teaching them with the proper worksheets. Also, on every Tuesday and Friday, I'll be dropping these videos. You just need to subscribe so that whenever I'll drop the video, you'll get the notification. So let me start with the question number 1. It says simplify and solve the following expressions. So I have already explained how to simplify, and if you are not aware of it, you can go to my video and see how to do it. So, well, I have explained that in order to simplify, we have to prime factorize the number which is inside the root, or what we can do, we can just simply write in this manner. That means 300 can be written as 3 times 100. That means splitting the number into a square number and a non-square number. Try to split it. Either prime factorize, that means find all the prime numbers that when I multiply them will give me 300. Or what you can do, you can try to split this number into such a way, into 2 numbers or 3 numbers, such that one number or 2 numbers should be. At least one number should be a square number. Just like here, 300 can be written as 3 times 100. 100 is a square number. It's a perfect square. That means when I take the root of it, it will give me an integer. Similarly, I can try for 75, and obviously it's 25 times 3. I know I can find the root of 25. So, this can be written as root 3 times root 100 minus 3 times, like in root 25 times root 3. So root of 100 is 10. So 10 root 3 minus 3 times root 3, and it's 5. Root of 25 is 5. So this will be 10 root 3 minus 15 root 3, and final answer is minus 5 root 3. Other method was the prime factorization, and this is a very long method actually, but still we can try. That means 300 can be written as 3 times 2 times 5 times 2 times 5 minus 3, and 75 can be written as 3 times 5 times 5. Now I just need to take out the pairs, that's it. So taking out the pair, that means 5 and 5 one pair, write 5 out there, 2 and 2, write 2 out there, and 1 which is unpaired will remain inside the root, so which is root 3, minus pairs 3 times 5 root 3. So this is 10 root 3 minus 15 root 3. Answer is minus 5 root 3. You can opt for any of these methods. Now moving on to the next one, root 63 times 100. I can split 63, 100 can be split into root 63 times 100. One more time I can split 63 into 9 times 7. So we know that 9 is a perfect square. So 9 times 7. And this is 252. So for that, if it's not coming in your mind like instantaneously what it could be, what you can do, you can just go for prime factorization. Here I'm using factor tree method, so it's 2 and this will be 1 2 6. This is 2 63, and we know 63 is what? 9 times 7. So now 63 is 9 times 7, and already 2 and 2 in pairs. So 9 root of 9 is 3, root of 100 is 10, and this is root 7, plus root of 9 is 3, 6 is already there, and pair 2 and root 7. This can be written as 30 root 7 plus 36 root 7, and final answer is 66 root 7. Moving on to the part C, still we have to do the same thing. That means we have to simplify. So root 3 can be written as 3 times 100 minus 5, and 27 can be written as 10 times 3. And root 192 can be written as root 16 times 12. And further, 12 can be written as 4 times 3. So this will be 10 times root 3 minus 3 times 5 root 3 over 16. The root of 16 is 4, root of 4 is 2. It's 8 root 3. So finally I can write 10 root 3 minus 15 root 3 over 8 root 3. That is negative 5 root 3 over 8 root 3. Cancel it out. Answer is negative 5 over 8. Moving on to the question number 2, which is expand and simplify. So this is the basic expansion that you have seen in algebra also. That means multiply first term with the first term, first with the second, second with the first, second with the second. That means every term of the first bracket you have to multiply it with every term of second bracket. That means 4 will be multiplied. So 4 will be multiplied with 6 minus 5 root 2, and plus 3 root 2 will be multiplied with every term of the second bracket. And now we can simplify, which will give me 24 minus 20 root 2 plus 18 root 2 minus 15 times 2, 30. This can be simplified as minus 2 root 2 minus 6. Or you can just take out, because either you can write it like that or take out negative 6 out as negative 1 out as common. Both are fine. 2 minus root 2 times 5 plus root 3. So 2 times 5 will give me 10. Then 2 times root 3 will give me 2 root 3. Then minus root 2 times 5 will give me minus 5 root 2. And minus 2 times root 3 will give me minus root 6. And I can't simplify it because there is no like term. So it will be written as it is. Moving on to the next one. This is very simple. The formula we have already studied in algebra, like in simple GCSE Maths. A plus b times a minus b will directly give you a squared minus b squared. And similarly, 5 root 2 and 5 root 2, they both are exactly the same. Only difference is in their sign. One is positive, one is negative. So answer is directly a squared minus b squared, which is 5 squared minus root 2 whole squared will give me 25 minus 2, which is 23. And that's the answer. Moving on to part D. Let me just zoom it a bit. 5 minus root 5 whole square means, this is the most common mistake I would be saying, because I've been tutoring for last 6 to 7 years, and I have seen this like 80 to 90% of students they do this mistake. They square 5 and they square root 5. No, it's in the case of when a plus b times a minus b, a squared minus b squared. You don't have to square this and square this. Is utterly wrong. 5 minus root 5, that means 5 minus root 5 times 5 minus root 5. And now multiply this. So 5 times 5 will give me 25. 5 times negative root 5 will give me minus 5 root 5. 5 times negative root 5 will give me again minus 5 root 5. And minus root 5 times minus root 5 will give me minus plus 5. Minus will become plus, and root 5 times will give me 5. So final answer is 30 minus 10 root 5. And that will be your answer. Moving on to the question number 3, solve the following equations. So basically here, if it's written as equation, that means definitely there must be any variable in that, and here it's y and we are supposed to find the value of y. For that, obviously we have to simplify it. So root 250 can be written as 25 times 10 minus y root 10 over root 2 is equals to 3 root 5. So this will be 5 root 10 minus y root 10 over root 2 is equals to 3 root 5. Now I can take out root 10 as common. It will be 5 minus y over root 2 is equals to 3 root 5. What I can do, it's a basic thing, what we always do in algebra, multiply both the sides by root 2 multiply. Either you can just cross multiply or multiply denominator to both the sides, will give me root 10 5 minus y is equals to 3 root 5 times root 2 will give me 3 root 10. I can clearly divide both the sides by root 10 will give me 5 minus y is equals to 3, and from here y is equals to 5 minus 3, that is 2. So the final answer is 2. Similarly, we have to find the value of y in part B as well. So it says root y plus 5 over 2 plus 2 root y minus 6 over 3 is equals to 4. Okay, so this is a simple, like it's kind of, or it's like an algebraic fraction. So what we do when we have two different fractions, not algebraically, even like in numbers, if we have arithmetically we have the fractions, we always find the LCM. That means we try to make the denominator same. Clearly the LCM of 2 and 3 is 6. So I have to multiply this with 3 to make the denominator 6 and this with 2 to make the denominator 6. So obviously if I'm multiplying the bottom with 3, so we have to multiply the numerator with 3 as well. Because in mathematics we can't do anything from our side and change the value entirely. We don't have to do it, we just have to make a balance. So this will become 3 times root y plus 5 over 6 plus, this will be 2 times 2 root y minus 6 over 6 is equals to 4. By making the denominator same, I can add all the numerator terms. So this will give me, now let me just expand this, 3 times root y will give me 3 root y plus 3 times 5 will give me 15 plus 2 times 2 root y will give me 4 root y and 2 times 6 will give me minus 12 over 6 is equals to 4. This will give me 3 root y plus 4 root y will give me 7 root y and 15 minus 12 will give me 3 over 6 is equals to 4. In order to find this, obviously I need to multiply both the sides by 6. It will give me 7 root y plus 3 is equals to 24. Subtracting 3 to both the sides from both the sides will give me 21. Divide 7, I'll get root y is equals to 3, and obviously to get the value of y I have to square it. So that will give me y is equals to 9. This is how we can find the value. Question 4 says find the ratio of P to Q if P is equals to root 300 and Q is equals to 7 root 27. It's simple, we just have to simplify first and then we can find the ratio because we can cancel them out. So P is equals to root 3 times 100, which is 10 root 3. Q is 7 root 9 times 3. That means 3 I'll take out as obviously because 9 is a perfect square. So this will be 21 root 3. And then we have to find the ratio. That means 10 root 3 P over Q, which is 21 root 3. So root 3 will be cancelled out, and 10 and 25 there's nothing common, so I'll write 10 over 21, and since it's about the ratio, I'll be writing 10 ratio 21. Moving on to part B, P is 7 root 32. Well, I can just simply write 32 as 16 times 2 P. So this is, take out 4 out as common, so 4 times 7 is 28 root 2, and Q is 128 is actually 64 times 2, so 64 times 2, 21, and root of 64 is 8 root 2, which is 168 root 2. And now let me divide and find the ratio. So this will be P is 28 root 2 over 168 root 2. Cancel this out. Obviously I can cancel this by 4. So this will be 7 and this will be 42. Again I can cancel 7 times 1 and 7 times 6. So final answer is 1 over 6, or ratio is 1 ratio 6. Moving on to the question number 5. Find the value of x in the following equation. So it means the equation is x over root 5 plus root 5 is equals to root 75x plus 3 over root 45. Now let me simplify it. So the first thing is we have to find, because we are adding, so it's better if we find the LCM and find the answer. Obviously the denominator of this is 1, so the LCM is root 5. So I have to make this root 5. So how can I make this root 5? X over root 5. I can make this by multiplying root 5 and dividing root 5 is equals to, simplify, root 75 is 25 times 3 x plus 3 over 45 is 9 times 5. So this is written as x plus root 5 times root 5 is 5 over root 5 is equals to 5 root 3 x plus 3 over 3 root 5. I can cancel out 3 and 3. This would be written as x plus 5 over root 5 is equals to 5 root 3 x. Multiplying both the sides by root 5 obviously will give me x plus 5 is equals to 5 root 15 x. Now move this onto the right hand side to get the value of x obviously. So 5 is equals to root 15 x minus x, or I'm writing it here, taking out x as common, 5 root 15 minus 1 is equals to 5. Divide both the sides by 5 root 15 minus 1. So this will be 5 over 5 root 15 minus 1. Well, this is not the acceptable answer because there shouldn't be a surd number in denominator, and for that we just have to rationalize it. I'm not rationalizing it here because this is the part I have divided the theory into 2 different parts. That is, one part was where I was explaining the simplification and the basics, and other was rationalization. So when we will be doing rationalization sheet, there I'll explain it in detail. I'm not saying to leave your answer like this. The final answer will be the rationalized answer, but I'll explain you there. If you have already aware of rationalization, I can show you here as well. It's fine. So this would be 5 over 5 root 15 minus 1. So multiply 5 root 15 plus 1 over 5 root 15 plus 1. We rationalize the binomial terms with the opposite sign. So this will give me 25 root 15 plus 5, and this one will be 374, and this is your final answer. Question 6 says a conical tent has a base radius of 2 root 2 plus 3. If the vertical height of the tent is 3 root 2 minus 2, find the surface area of the tent. Obviously, if we are talking about this tent, the base should be open, right? Obviously, the tent is only, it's this curved part. There is no base circle in this case. So, in that case, we have to find pi RL only, this one. We know for this tent, this is vertical height, this is slant height, and this is radius. So tent, they have given the base radius as 2 root 2 plus 3. The vertical height is given as 3 root 2 minus 2, and this is a right triangle. So basically we have to apply Pythagoras to calculate the slant height, because the curved surface area has L in it, so that's important. So which means 2 root 2 plus 3 whole squared plus 3 root 2 minus 2 whole squared will give me L squared. This is 8 plus 9 plus 12 root 2 plus 18 plus 4 minus 12 root 2 is equals to L squared. This will be 18 plus 8 plus 4 plus 9, that is 39, is equals to, let me check, it's 18, yeah, plus 8 plus 9 plus 4, 39, and 12 root 2 minus 12 root 2 will give me 0, is equals to L squared. Then, so your answer will be L is equals to root 39. Root 39 is slant height. So final area will be pi RL, which is pi. Radius is 2 root 2 plus 3. So I'm writing it here. Pi times L times radius 2 root 2 plus 3. Or we can say this will give me pi 2 pi times root 78 plus root 39 times 3 will give me 3 root 13 pi, and that will be your answer, centimeter squared. Now question 7 says y plus root 75 whole squared can be written in the form of x plus 30 root 3. Then expand and simplify root x minus root 189 in the form of a root b, where a and b are integers. So y plus root 75 whole squared, first of all we can write root 75 as 25 times 3, which then can be simplified as 5 root 3 whole squared. Then if I expand this, because y plus 5 root 3 whole squared means y plus 5 root 3 times y plus 5 root 3, this can be written as y squared plus 75 plus 10y root 3. This can be written as x plus 30 root 3, that's mentioned up here. So I can clearly see root 3 term are equal. I can compare them obviously. So 10y root 3 is equals to 30 root 3. From here I can find the value of y be 3. So if these two are comparable, this one and this one, that means x and y squared plus 75 are equal. So x equals y squared plus 75. We just solved y as 3. That means x is equals to 9 plus 75, which is 84. So we have found the value of x. Now we have to simplify and find this value. That means root of 84 minus root of 189. But we have to simplify it further. We know 84 can be written as 21 times 4, whereas 189 can be written as 21 times 9. So from here I can write 2 root 21 minus 3 root 21, which is actually root 21. This is our simplified answer, where A and B are integers. On compare, I get A as 1 and B as 21. Moving on to the question number 8. If first three terms of an arithmetic sequence, an arithmetic sequence is a sequence in which you keep on adding the same number or same constant to get the next term. So like if my series is 1, 3, 5, clearly I'm adding 2 and 2 and 2 and so on to get the next answer. So here, because we are adding a constant term, I'm not sure what that constant number be, so let me assume it to be d. So when I'll add d to it, I'll get 2 root x. That means root x plus 1, when I'll add d to it, will give me 2 root x. Again, if I'll add d, because the constant number I have to add, that will give me 11. That means when I'll add d to it, I'll get 11. From this, I can write d is equals to 2 root x minus 1. And from here, it will be 11 minus 2 root x. And I can just simply equate. So 2 root x minus 1 is equals to 11 minus 2 root x. Bring it here. 2 root x minus 2 plus 2 root x equals, and bring it here, 11 plus 1. This is 3 root x is equals to 12. Divide both the sides by 3. Root x is equals to 4, and squaring both the sides, x is equals to 16. Hence, we got our value as 16. Now, find the 8th term of the series. So, once we have the value of x, it's easier to find our series, what actually that series is. Root x plus 1. Root 16 plus 1 is 5. Then 2 root x, that means 2 times 4, which is 8, and 11. You can clearly see what constant number we are adding, 3 to get the next term. So what will be the 8th term of this series? An arithmetic sequence, there is either this is a linear equation, you know, right? The linear sequence, you can solve it by that, by the linear sequence, or you can use the formula, which is a plus n minus 1d, which is the formula for arithmetic sequence. So you can solve arithmetic sequence by linear sequence. How you solve linear sequences? Because arithmetic sequences are basically linear sequences. So either you can solve by that, or you can use the formula. If you don't know from where this formula came, and you're not aware of arithmetic and geometric sequence, don't worry, we'll be doing it and I'll upload it. For this one, I'm just directly writing the formula, and you can carry on with your linear sequence term. And if you're not even aware of how to solve it, I have already posted it on my channel. You can go and see it. So a is the first term, n is the number of terms, and d is the constant term that you are adding constantly. So first term is 5 plus, they're asking 8th term, that means n will be 8. And the constant number that we are adding is 3. So 5 plus 7 times 3, which is 26. So that's your 8th term. If the last term of this series is 65, find the number of terms of the series. So again, I'll be using a plus n minus 1d. Here n is n, that is your last term. And that term is 65. Our first term was 5, a is 5. 3 minus times n minus 1 equals 65. Subtracting 5 to both the sides, 3 times n minus 1 is equals to 60. Divide 3 to both sides, n minus 1 equals 20 and n is equals to 21. So there are 21 terms in this series, whereas 21st term is 65 itself. Simplify the following expression, a to the power of root 8 times, so I'm just writing a to the power of root 8 times a to the power of root 128 over a to the power of 72 whole root 2 is equals to 6561. So let me simplify these Surds number first of all. So we can say a root 8 can be written as 2 root 2 times a. 128 is what? 128 can be written as 4 times 32 or 4 times 16 times 2. This is how we can split into the square numbers. So that will give me 8 root 2 over 72. Now 72 can be written as 36 times 2, 9 times 4 times 2. That means 6 root 2. So A is 6 root 2 whole root 2 is equals to 6561. Now we know basic indices. That means if you are multiplying two indices having the same base number, the power gets added. Remember, it has to be same base number, power gets added. So A is equals to 2 root 2 plus 8 root 2 over 6 root 2. That is 6561. And if you are dividing this indices having the same base number, the power gets subtracted. So that means if I add this one, it will give me 10 root 2. And this one has to be subtracted, minus 6 root 2. So this is finally 4 root 2. And if there is a power over another power, we just multiply them together. That means this will be A, 4 root 2 times root 2 will be 2. So A to the power of 8 is equals to 6561. Now 6561 can be written as 3 to the power of 8. So A to the power of 8 is equals to 3 to the power of 8. On comparing, I'll get A is equals to 3. And that's your answer. So that's it for today. If you're looking for online classes, they are at just £6 per hour, whether it's further maths, for GCSE maths, for any subject, triple science, combined science, for English, they all are just £6 per hour. And also if you're looking for classes from year 1 to A levels, it's at very affordable rates. All you need to do is just drop us an email at exactadmin@gmail.com for the free demo, to book your free demo. And also if you're looking for free worksheets, they are available at our website, which is exactadmin.com. So that's it for today. Bye everyone. Take care.